Hi guys, this is Mr. Zimmerman, and I'm going to show you how to identify the half-life of an exponential function. So after you read the problem, you'll get the Mandalorian reference. And essentially he drinks a potion that has 80 milligrams of caffeine, and he's trying to figure out how long the caffeine will stay in his system. Well, to start, what is a half-life? And a half-life is exactly what it sounds like. It's a rate that is 50%. And after a certain amount of time, when only half is remaining, that is going to be a half-life. So it's T hours where only half is left. So let's go ahead and look at it. To understand the situation, we're going to go ahead and analyze how long it's going to be in 0 hours, 5 hours, 10 hours, 15 hours, and 20. And the reason I use the multiple of 5 is because it has a half-life of 5 hours. So if Baby Yoga drinks 80 caffeine, that's how much he's starting with. How many cycles has he gone through yet? 0. Now, in 5 hours, he would have gone through 1. In 10, 2, 3, and 4. Now, he's going to have half remaining. So it's going to be 40, 20, 10, and 5. Now, I urge you to think, instead of thinking division, I want you to think about it as repeated multiplication of 50%, which we're going to multiply repeatedly. So it's going to be 0.50 to the t. Now, we need to represent the amount of caffeine remaining in t hours. We're going to have to do a couple of things to make it match the half-life of 5 hours. So we're going to go ahead and write our function, a of t, where time is the input, and time this time is hours. Be aware of that. So how much did he start with? 80 milligrams of caffeine. And now we're going to have to take 1 minus our rate because it is a decay. And what you're going to notice is that it's going to be exactly the same percent. This is the only instance where this will behave this way, because if you take half of 1, you're going to be left with exactly half. So we're going to put it in our equation as 0.50, and we're going to raise it to the t power. Now, using apps like Calculate 84, we're going to examine the outputs when a of t is 1, 2, and 3. I urge you to look at the table, and you're going to see that it does not match this table of values. Now, this is the extra trick, but in order to know why we put 5 where we do, we're going to go ahead and look at the table. So we want it to match. Now, it has a half-life of 5 hours. That means I don't want this to occur every hour, but I only want it to occur. How do I say this? I only want it to occur. Do you notice how this 5 became a 1? And this 10 became a 2? And this 15 became a 3? And this 20 became a 4? What did I do to the amount of hours each time? I divided it by 5. I did this because the half-life is 5 hours. I want my exponent to match my number of half-life cycles.